Hi, my friends. Good morning. Good morning. Welcome to my channel, Belagali's classes. Belagali's classes. Yes, my friends. In the previous video, started with the derivatives of a functions. So I gave the definition of what? Dy by dx or f dash x. Yes, you know, with the help of what? Derivative of a function at a point x equal to a, I give the definition by substituting x minus a equal to h. That h, capital delta x, small delta x, they are nothing but increments in x. Increment in x is either it is a increase in the value of x or decrease in the value of x. Is correct? Yes, that is called as increment. An increment in x is denoted by either the letters h, capital delta x, small delta x. Similarly, with respect to y, k or capital delta y or small delta y, delta y by delta x or k by h, they are called as what? Incrementary ratios. Everything I explained, my friends. Then with the help of that, we get the definition of what? Dy by dx. Dy by dx is nothing but limit as h tends to 0, f of x plus h minus fx upon h. Otherwise, in terms of delta x, again delta x is what? It is a change in the value of x, increment in x. Instead of h, if we consider delta x, then the derivative of dy by dx or f dash x equal to limit as delta x tends to 0, f of x plus delta x minus fx upon delta x. By making use of that, last year only, this is a definition of not this year, just a remind. In PUC first year, we have done, by making use of this definition, derivatives of algebraic functions by first principles. Why? Finding the derivative of a function by using the definition is known as finding the derivative of a function by first principles. My friends have done algebraic functions last year. Derivative of constant, derivative of x to the power n, derivative of root x, like that, my friends have done. Even all 6 trigonometric ratios you have done. Derivative of sine x, cos x, tan x, everything you have done. But when the exponential functions comes, logarithmic functions comes, these are not done at PUC 1 level. Exponential means e to the power x, e to the power x. That's why in the previous video, they are there in our textbook. Last page they have mentioned derivatives of e to the power x, e to the power x by first principles. They have mentioned, as they are mentioned in the previous video, I have done it. Derivative of what? E to the power x with respect to x by first principles, e to the power x with respect to x by first principles, and one general I have done. Sometimes in the exam they go for what? Find the derivative of e to the power 3x, 5x, 7x, like that by first principles. I have done in general e to the power ax with respect to x by first principles. Then I have done even e to the power x. Yes, my friends, these are with exponential functions. Saying in that last line there about logarithmic functions. Logarithmic functions are nothing but what? Log x to the base e, log x to the base a. Again, I went through the books, man. They have not mentioned about their proofs as they have mentioned about exponential function e to the power x, e to the power x. They have mentioned, done. They have not mentioned, I am not going to do the proof, but we wanted their derivatives. Directly, I give a derivative of log x to the base e with respect to x, log x to the base a with respect to x directly as a formula. Yes, take it granted, prepare them by after. Yes, my friends. What next? Once again, just a revision of your PUC first year. What is done at PUC 1 in algebraic functions, derivatives of algebraic functions. Next, trigonometric functions, exponential functions, like that we do one by one, my friends. First one, derivatives of algebraic functions. First one, algebraic functions. Yes, my friend. What is k? K is any constant. Derivative of any constant is 0. Therefore, constant means comes from, my friends, derivative of 5 with respect to x. What is this? And derivative of minus 7 with respect to x. Again minus 7 plus 5, they are all what? Zeros. Don't write when it is plus here plus, when it is minus here minus. These are nothing but, my friends, they are the constants. So derivative of any constant is 0. This is first one. Second, derivative of x to the power n. What about n? N is any rational number. N is any rational number. Yes, my friends. N is a rational number means, then what is it? N is a positive integer, n is a negative integer, n is a fraction, p by q, n is a fraction. So, for all varieties of n, my friends, where the power is positive, negative fraction, what is the formula? That formula tells derivative of x to the power n with respect to x is what? N power as it is into x to the power n minus 1. What is n minus 1? 1 less to the power. It is 1 less to the power. Therefore, derivative of x to the power n with respect to x is power into x to the power 1 less than the given. Therefore, my friends, here derivative of x to the power 3 with respect to x, 3 into x to the power n minus 1, 3 minus 1, what is 3 minus 1, 2. Henceforth, I am not going to write in detail like this. What is it? Power into 1 less. X to the power 100 into x to the power 1 less. 1 less to the 100 means 99. Yes, my friend, derivative of x here. Tell my friends, what is the power here? 1. Then n into x to the power n minus 1. N minus 1 means 1 minus 1 is 1. Otherwise, you can write this is 1 into x to the power 1 minus 1. What is 1 minus 1? 0. Then what is it? It is 1 into 1 means 1. Therefore, derivative of x to the derivative of x with respect to x. Derivative of x with respect to x is 1. X with respect to x is 1. Yes, my friend. While doing the examples, if it comes, no drama like this, 1 minus 1, no. Directly you can write its derivative is 1. Like this, my friends, even though it is done last year, once again remind, root x, root means what? Power of x, converting in terms of p by q, 1 by 2. Use n into x to the power n minus 1, n into x to the power n minus 1. What is it? Simplification. Minus half. You push it down. It is 1 upon x to the power half. What is x to the power half? Root x. Therefore, my friends, derivative of root x with respect to x is 1 by 2 root x. 1 by 2 root x. Now you can treat as a formula, my friends. Treat as a formula. Derivative of root x with respect to x is 1 by 2 root x. 1 by 2 root x. Next, this. What is here? X to the power n is in the numerator. What is this? It is x to the power n in the denominator. It is derivative of 1 upon x to the power n with respect to x. As this. Lift the numerator minus n. Apply the formula minus the power x to the 1 less to the power. Your power is minus n. 1 less means minus 1. Once again, my friends, push it down. X to the power minus becomes plus, n plus 1. So, it is what? Minus n upon, this is simplifying, minus n upon x to the power n plus 1. So, derivative of 1 upon x to the power n is what? Minus the power x to the power n plus 1 means 1 more. Then how to remember, my friends? When it is in the numerator, plus here, plus. plus power into x to the power 1 less. When the same is in the denominator, minus the power upon x to the power, there 1 less, here when it is in the denominator, it is 1 more. Therefore, applying the same here, 1 upon x to the power 2 minus n minus the power down x to the power 1 more. 1 more means what? 2 plus 1, 3. Yes, similarly while writing derivative of my friend, it is 1 upon x to the with respect to x. What is the power here? 1. What is it? Minus 1. Denominator x to the power 1 more. 1 plus 1 is 2. Like that, my friends, you can write derivative of 1 upon root x. Root x with respect to x. Yes. What is it? D by dx of my friend 1 upon x to the power half. Yes, my friend. Sign changes, plus changes to minus. Here also see, plus changes to minus. Here also it is plus here, it changes to minus. Plus changes to minus. Minus half n. X to the power 1 more. 1 by 2 plus 1. 1 by 2 plus 1 will be what? 3 by 2, my friends. 3 by 2. Therefore, basically, you consider 1 derivative of constant is 0. Second, derivative of x to the power n is n into x to the power n minus 1. And derivative of 1 upon x to the power n minus n upon x to the power n plus 1. And what is root x? Is 1 by 2 root x. Yes, my friends, in algebraic functions, this is 1, this is second. I treat this man. Why? It helps us to write like this, direct. Minus 2 upon x to the power 3. Like that, my friend, even it is what? Derivative of, it is 1 upon x to the power 5. Yes, directly write it. Down means minus the power upon what? 1 more x to the power 6. Like this, my friends, you can write the derivative. It helps. From the beginning only, I treat this as a formula because even in future related with mathematics, if you join engineering, this is a very, very useful formula, my friends. Useful. Okay? Root x. I hope it is clear. Writing for my sake once again. Yes. Yeah, your power is any rational number. Remember, my friends. Yes, my friends. No, derivative of k is 0. Second, derivative of x with respect to x is 1. Yes. Derivative of x to the power n with respect to x. N into x to the power n minus 1. Next is derivative of 1 upon x to the power n with respect to x is what? This is minus the power upon x to the power n plus 1. Yes, my friends. Derivative of constant is 0. Derivative of x with respect to x is 1. Derivative of x to the power n with respect to x is power into x to the power 1 less. If it is in the denominator, it is minus the power down x to the power 1 more. If it is n, 1 more means n plus 1. 1 less means n minus 1. Yes, my friends. Remember. Then I give some tips. Tips means they are the tips while doing the examples, my friends. These are the tips while doing the examples. While giving the examples. Yes, my friend. Yes. Once again, my friends, if u is any function of x, if u is any function of x, then derivative of ku, what is it? Function is multiplied by the constant, then what is k? It is a constant coefficient of the function. What is its derivative? k into derivative of u with respect to x, du by dx. So while writing the derivative of this, my friends, ku, where k is, what is k? It is a constant coefficient. It remains as it is. If it is 5 here, remains. If it is 10, remains. If it is minus 10, that minus 10 remains. Into, you have to write the derivative of this function with respect to x. Yes, my friends. So, keeping this in the mind, you can write the derivatives. What is it? Derivative of kx, I told that k is out, into derivative of x with respect to x. What is this, my friend? K into derivative of x is 1, so it is k. So from this, what is clear? This is the tip, my friend. Derivative of kx with respect to x. With respect to x is k. Yes. Yes, my friend. While doing, man, I am writing directly. What is derivative of 5x? 5x with respect to x. Derivative of 5x with respect to x. Derivative of 5x with respect to x. Direct you can write. What is that? Constant coefficient 5. So derivative of minus 10x. Minus 10x with respect to x. What is it? Minus 10. Then what is the derivative of minus x with respect to x? Is minus 1. Yes, my friends. So in this case, no need take 5 out into derivative of x, nothing. If you remember this, derivative of kx with respect to x is k, that constant. If this is there, direct 5, direct minus 10, direct minus 1 like this, man. It helps. This is 1. This is 1. Yes. Next, second. Yes, my friend. Derivative of k into, this is there are k here. I take here also k into x to the power n with respect to x. Then k is out into derivative of x to the power n with respect to x. My friend, k into n into x to the power n minus 1. Therefore, this is your second tip. What is it? Derivative tip. X to the power n with respect to x. My friend, what you are saying? You are multiplying both direct kn into derivative of into x to the power 1 less to this. Don't take 1 less of this. It is 1 less to the power n minus 1. This is tip, my friends. Tip. Yes. Therefore, while writing, you can write direct. Derivative of 5x to the power 3 with respect to x. 10. 5 into 3, 15. X to the power 1 less. 3, 1 less means 2. Like that. Derivative of minus 7 into x to the power 6 with respect to x. Tell my friend, minus. How much? 42. X to the power 1 less 5. Like this, my friends, you can write direct while doing examples. This you can write direct while doing examples. There is no confusion, my friends. Yes, this is the second one. This is the second one. Third is derivative of k upon x to the power n. K upon x to the power n with respect to x. See, this is k into d by dx of 1 upon x to the power n. Tell my friends, k outside derivative sign, k outside derivative sign, k outside derivative sign. What is left inside? 1 upon x to the power n. My friends, you know this formula. K into L minus n upon x to the power 1 more n plus 1. If you simplify, it is minus kn down is x to the power n plus 1. X to the power n plus 1. Therefore, yes, my friend, derivative of k upon x to the power n with respect to x. This is sign change minus. You have to multiply these two, my friends, k into n, kn, see there, kn, multiply these two, kn, what is down? 1 more n plus 1. This you can treat it as what? Another tip in differentiation while doing the examples, we can make use of it. Therefore, derivative of 2 upon x to the power 5 with respect to x. Yes, sign change minus 2 into 5, 10. Down is x to the power 1 more 6. Like this, man, even derivative of minus 3 by x. Minus 3 by x, can my friend. Sign change means plus. 3 into, what is the power of x here? 1. What is 3 into 1? Is 3. Down, 1 power more. More means what? X square. More means x square. Yes, my friends. By making use of the known things, what is there known? Derivative of x is 1. Derivative of what? X to the power n. 1 upon x to the power n. The same thing other than x. Other than x to the power n. Other than 1 upon x to the power n. By making use of this property, derivative of ku, k into du by dx, you can write derivative of kx. Kx is k itself. Derivative of kx is k. So 5x is directly 5. Yes, my friends. Next is this k into x to the power n. Direct kn into x to the power 1 less n minus 1. Derivative of k into x to the power n is these two have to multiply. Coefficient multiplied by the power into x to the power 1 less of power. Same. K upon x to the power n. It is sign change plus minus plus sign change. But multiply these two, my friends, k into n upon 1 more x to the power n plus 1. 1 more. Even verified with some of examples here. Yes, my friends. This is about derivatives of what? Algebraic functions, including this derivative of root x with respect to x is 1 by 2 root x. 1 by 2 root x. Yes, my friends. Yes, my friends. These are just the list, the tips what we have in case of what? Algebraic functions. Once again, remember, derivative of constant, single constant is 0. Other than kx. Derivative of kx is k. Kx is k. Yes. X to the power n. N into x to the power n minus 1. If it is k there, k into n. That's what. 1 upon x to the power n. Minus n upon x to the power n plus 1. The same thing with what? K. Multiplication. Sign change when it is in the denominator. Minus k into n upon x to the power 1 more. And derivative of root x is what? 1 by 2 root x. 1 by 2 root x. My friends, I treat these are what we wanted from the algebraic derivatives of algebraic functions. Yes, my friends. Next comes trigonometric functions. Trigonometric functions. Remember, in algebraic 1, this is 2, this is 3, this is 4, this is 5, 6. and this root x is what? 1 by 2 root x. Repeatedly, if you use them, you can very well remember. This is derivatives of algebraic functions. Algebraic functions. Next is trigonometric functions. Next is trigonometric functions, derivatives of trigonometric functions. Trigonometric functions. Trigonometric means, my friends, there are mainly 6. First, a derivative of sine x. Sine x with respect to x is cos x. Next, a derivative of cos x. Cos x with respect to x. We have done all these by first principles. By first principles we have done at PUC 1 level, means at 11th standard. Derivative of cos x is minus sine x. Yes, my friend, this is one pair. Second pair, derivative of tan x. Derivative of tan x with respect to x is sec square x. This is sec square x. Tan and sec always related. Derivative of cot x. Cot x with respect to x. What is it? It is minus cosec square x. This is second pair. Third derivative of sec x. Sec x with respect to x is what? This is sec x into tan x. Derivative of cosec x with respect to x. This is minus cosec x into cot x. Minus cosec x into cot x. Yes, my friends. I have written these 3 separate instead of listing all 6. Yes, my friend. See, derivative of sine is cos is minus sine. Change is in between. Then the derivative of tan is sec square, cot is minus cosec square. Why, my friends? Even in PUC, no, even in 10th standard, while proving the identity, what we have done? 1 plus tan square is sec square. 1 plus cot square is cosec square. There is a relation between what? Cot and cosec square with 1 plus cot square is cosec square. 1 plus tan square is sec square. They are the Jodi. Okay, friends, Jodi. Yes. So tan sec square, cot minus cosec square. Sec into tan. See, once again the relation between sec and tan only. Derivative of sec is sec into tan x. Cosec is once again between the two. Minus cosec into cot x. It becomes very easy to remember. Tell what is one more observation. Derivative of cos minus derivative of cot minus cosec square. Derivative of cosec minus cosec into cot. See, it is a derivative of a trigonometric ratio. Starts with letter C. Letter C have negative sign. Therefore, in general, you can very well remember derivative of a trigonometric function that starts with a letter C. Letter C has what? Negative sign. Remaining, my friends, what are remaining? It is not C plus. It is not C plus. It is not C, it is plus. That's why I have writing them as what? 3 pairs. Sine cos, tan cot, sec cosec. You know the derivatives. And one more, my friends, really it is important. In general, This angle is x. Derivative of sine. My friend, I have taken ax here. What is this ax? It is an angle other than x. Other than x. Other than x with respect to x. My friends, in this case, I have proved it. What is that? Derivative of e to the power ax with respect to x. What is the formula? My friends, exponential as it is into if it is other than x into a coefficient, other than x into a coefficient. Same thing you use here. What is the derivative of sine cos? If the angle is x, write angle is x. If the angle is other than x, write it. Yes, ax. Is it x? No. Then write its coefficient. It is very simple, very easy to remember. Is it x? No. Write its coefficient. Is it x? No. Write its coefficient. Here, my friends. Instead of this man, if I take d by dx of sine ax plus b or ax minus b, ax plus b or ax minus b. Once again, what is derivative of sine cos? What is it? Ax plus b. Your question mark, my friends, after writing sine cos, whatever the given angle is there, you write it as it is, no change. Given angle, write as it is. After writing this, next man. Question, is it x? No. Why? X is here. If x is there, it remains the same. Derivative of tan x is this. Derivative of sin x is cos x. Is it x? That is the derivative. If it is other than x like this, if it is other than x means write its coefficient. Other than x means write its coefficient. What is it? Coefficient of x. What about this constant? Anyway, it is a constant whose derivative is 0. So it is a itself. Therefore, my friends, while writing, it is derivative of cos 2x with respect to x. Tell my friend. Cos. What is the derivative of cos? Minus sine. This is minus sine. This angle as it is, given angle as it is. After writing this, your question comes. Question it. Are you a friend? Friend means what? X. He says no. No. When it is no, what is into? 2. What is it? Coefficient of x. Coefficient of x. At present, remember, I will tell later. Why tell? As you know, the derivative of kx is k. What is derivative of 2x? 2. Here, kx is k. You have to write its derivative if it is other than x. What is the derivative of ax? A. If it is other than x, write its derivative. See here. What is it? X. What is the derivative of x? Derivative of x is 1. That's why we are not writing here. If it is other than x, my friends, we must write its derivative. Its derivative. What is the derivative of this? Ax, a plus. What is the derivative of b? Constant 0. 0. 2x. What is the derivative of 2x? 2. Like this, my friends. So, another is d by dx of cos. It is 3x minus 4. 3x minus 4. 10. Derivative of cos is what? Minus sine. Whatever it is given, you have to write first. Whatever as it is, you write. 3x minus 4 into. Is it x? No. Then write the derivative of this angle. Otherwise, coefficient. Remember 1. Either the derivative, otherwise coefficient. What is coefficient? 3. What is the derivative? Kx is k. 3x is 3. Minus constant 0. 3 minus 0 is 3 itself. Like this, my friends. Another one. I write like this. Find dy by dx. Dy by dx of the following. Yes, my friend. This is in your book. Y equal to sine x plus 5 It is a 1 mark question, even it is appeared once in question paper also. In question paper also. Tell my friend. Tell. Dy by dx. Derivative of y is dy by dx. See, you have to write derivative of sine cos. I told angle as it is into derivative of this angle. What is derivative of x? 1. Otherwise, coefficient of x. What is coefficient of x? 1. 1. Derivative of x, otherwise coefficient of x, which is 1. Finished. 1 mark question. Like this, my friends, another one. It is also in your textbook. Under textbook, what is it? Derivative of sine ax plus b with respect to x. Sine cos as it is into derivative of this. What is the derivative of this, my friend? Ax is a plus b 0 plus b 0. Yes, friend. Another one is y equal to sec 3x. Yes. Dy by dx. What is the derivative of sec x? Derivative of sec x is sec x into tan x. Sec x into tan x. My friend, if it is 3x, what you have to do? You have to write 3x here into 3x. Is it your friend? No, sir. Then you have to write its derivative. 3x is 3. Yes, my friend. So, in this case, what is the derivative of dy by dx? Derivative of sec. Sec is sec into tan. Angle same. Angle same into coefficient or derivative of 3x is 3. 3x is 3. Yes, my friend. Y equal to tan of 2x minus 3. It is in your textbook and it is appeared in question paper under 1 mark. Appeared in question paper under 1 mark. 1 mark. Yes, dy by dx. Derivative of tan. See, derivative of tan sec square you have to write. Angle as it is. Next man, is it x? No. When it is not x, write its derivative or coefficient. Coefficient of x is 2. Yes, my friends. Yes, my friends. These are what? These are derivatives of trigonometric functions. Derivatives of trigonometric functions. Trigonometric functions. Yes, my friend. Derivative of sine, cos. Cos minus sine. Tan sec square. Derivative of what? Minus cosec square. Derivative of sec. Sec x into tan x. Sec x into tan x. Derivative of cosec minus cosec x into cot x. My friends, once again I will repeat, derivative of any trigonometric function starts with letter C. Letter C. How? Minus sign. Derivative is minus, negative, minus. If it is other than x, if the angle is other than x, write its derivative, otherwise coefficient. Derivative, otherwise coefficient. Yes, my friends. This is about trigonometric functions. Next comes exponential and logarithmic functions. Next is exponential and logarithmic functions. Yes, my friend. Derivatives of exponential. And this is, my friends, second is trigonometric, third is exponential. Derivatives of exponential, I write in brief, exponential and logarithmic. Logarithmic functions. Yes, my friends. Yes. In exponential, you have three. Derivative of e to the power x with respect to x is what? E to the power x. What is second? Derivative of a to the power x. E to the power x is a to the power x into log a. It is understood e. This is e. Yes. How to remember a log a? A log a. If it is 3 here, 3 log 3, 5 log 5, like that. And I have done one general, my friend. It is d by dx of e to the power ax. Power is other than x. Same as it is other than x, right? Its coefficient or derivative. What is derivative of ax? A. Like this, even here also, my friend, it is derivative of a to the power bx with respect to x. E to the power bx. What is the power here? X. What is the power? Bx. It is x other than x. Your formula says first man as it is. As it is first into, is it x? No. Then no means, right, it's a derivative or coefficient. What is coefficient of x? B. Like this, my friends. These are about exponential functions. About the examples, everything we have discussed. We have discussed where? In the previous video. Then comes, my friends, logarithmic functions. Logarithmic functions. My friends, in this case, derivative of, there are two things. Derivative of log x to the base e, our usual base, with respect to x, is what? 1 by x. Yes, I told they have not mentioned about the proof, how we get it. When they have not mentioned means, I don't want to tax the students by giving its proof. Then you would remember it is 1 by x. Remember 1 by x. What is another one? 1 by x. What is another one? D by dx of log x to any base a is same first 1 by x into log e to the base a, man, here, that the change here is log e to the base a, log x to the base a, other than e, if it is e, directly 1 by x. If it is other than e, first you have to write 1 by x into, this is fixed e, log e to the base a. Therefore, derivative of log x to the base 10 other than e. What is it? This is 1 by x into log e is fixed, my friend. Then you have to write given this 10 here remains like that. Even if it is d by dx of log x to the base 2. Yes, my friend. Log x means 1 by x into log e to the base 2. Log e to the base 2. These are, my friends, in case of what? Exponential and logarithmic functions. Yes, my friends. Please remember. Derivatives of what? Algebraic functions. Given what list? Starting with derivative of constant k0, kx k. Derivative of kx is k. Then x to the power n. Derivative of x to the power n. N into x to the power n minus 1. If it comes k, derivative of k into x to the power n. Kn you have to multiply coefficient to each power. Kn into x to the power n minus 1. Next is 1 upon x to the power n minus n upon x to the power n plus 1. One more here when it is in the denominator. One less when it is in the numerator. Same. K upon x to the power n minus kn upon x to the power n plus 1. Last is derivative of root x. Root x is 1 by 2 root x. My friends, these are algebraic functions. Algebraic functions. If you know these perfectly, you can do the examples with speed. With speed. You can get speed there. About the trigonometric functions. Derivative of sin x is cos x. Cos x is minus sin x. Tan x is sec square x. Cot x is minus cosec square x. Sec x into tan x. Cosec x minus cosec x into cot x. If the angle is other than x, for example, derivative of cos 3x, derivative of cos is minus sine, write the angle as it is 3x. If it is other than x, write its derivative. 3x is 3. These are about the trigonometric functions. Exponential e to the power x. E to the power ax other than x into a. A to the power x. A to the power x into log a. It is what? A to the power x into log a. A to the power bx as it is. Derivative of bx. B. My friend, I have not written here. Log of the base. Log a to the base a. A to the power x. A to the power x log e to the base this. A to the power bx. Bx as it is. My friend, other than x, its derivative into what is this? Other than e. If it is e here, if it is e, only 1 by x. If it is other than e, no law. Only this that comes down, my friends. A to the power bx, a to the power bx into derivative of b, it is there, my friend. Other than e, log a, here it comes into log a to the base e. Yes, it comes. Sorry, not written. Log x to the base e, 1 by x. Log x to the base a, 1 by x into log e to the base a. Yes, 2 examples, my friends. These are all almost algebraic, trigonometric, exponential, and logarithmic functions. My friends, while doing the examples, all these 4 derivatives of 4 different functions, if you remember well, then examples becomes easy. Telling this, wishing you must do this perfect. I told the importance of calculus in future. Without calculus, there is no mathematics, especially if you join engineering anywhere. Calculus is needed, must. Yes, my friends. Saying yes. Remember all these things. Make it perfect. Yes, my friends. Thank you very much. Good day. Thank you very much.